Hello, math student. This is your tutor, Shungwana PE. Today, I will be taking you through differentiation of inverse trig functions. So, in this video, we'll only look at arcsine, arccos, and arctan. So, all these trig functions, they have their own specific formula that is used to differentiate. So, let's look at arcsine first. So, we'll look at them in that order. So, sorry, my marker was not coming out. So let's look at arcsine. When you are differentiating arcsine with respect to x, so d dx means I'm differentiating with respect to x. It gives me the following. And these formulas, they are given in formula sheet. So when you are writing your assessments, they will be given to you. So, but it's provided that as you are practicing and doing more and more problems, try to familiarize yourself with them so that in case they are not there in the formula sheet when you are writing, you are able to remember them. So this is the one for arcsine. So let's look at the one for arccos. When you're differentiating arccos with respect to x, so it is the same as the one for arcsine. The only difference is that this one has a negative, but the rest is the same. So lastly, when you are differentiating arctan, so the one for arctan, we have f prime at the top, but this time round, we don't have a square root. And also here, we don't have a minus sign. We only have 1 plus f of x squared. So these formulas have been derived by mathematicians. So, but in this video, we are not going to derive formulas. We are just going to apply them. So let's look at the first example. And we are still going to follow that order. So example 1, we can divide our screen. Example 1, we'll look at arcsine. Y equals to arcsine of 3x squared. I always advise my students that you must write the correct formula. That should be your first step. Write the correct formula. So check on your formula sheet, how do you differentiate arcsine? So you will find that we differentiate it using this formula. So that should be your first step, writing the correct formula. Then the next step, you check what is your f of x. Your f of x is 3x squared. Then the next step, you differentiate your f of x. When we differentiate 3x squared, we get 6x. Then lastly, we apply the formula. Now our dy dx becomes, our f prime of x is 6x when we are applying our formula. The square root, it's there, 1 minus, then we substitute our f of x, which is 3x squared, but the formula has a square also. And then we have to simplify our answer, because in mathematics, our answers have to be left in their most simplest form. So 3 square is 9, x square is x to the power 4. So we are done with differentiating arcsine. Let's look at an example that involves arccos. So we will call this example 2. I'm a person who likes to follow patterns, so we will divide our page again. Excuse my line is not straight, but I hope we'll be able to work with that. So I'm trying to use the most simplest examples for this lesson as we are trying to look at how the formulas work. So that is the formula, and the question says find dy dx, or differentiate the following question with respect to x. So we write the correct formula, it's dy dx. We said that this is the same as the one for arc sine, but the difference is that this one has a negative, so it's 1 minus f of x all square. So we say that the next step is to write our f of x, which is x squared plus 2. Then we differentiate that f of x, which gives us 2x. So lastly, we apply the formula. When we apply the formula, we have dy dx. The negative is there on the formula, but our f prime x, sorry, this is f prime x. Let me check on the previous if I wrote it correctly. Yes, on the previous example I wrote it correctly. So that's f prime x. Our f prime x is 2x all over the square root of 1 minus my f of x this time around is x squared plus 9 all square. We can try to simplify these to, because we can see that we are having brackets there. Then we're having 1. We will have x to the power 4 plus 18x squared plus 81. So as you work through the brackets inside that square root, you will end up having x to the power 4 plus 18x squared plus 80. So you can try to simplify and see that if you're having the same answer. You can pause this video as well and try to solve, but it's just, you can do it by only 2 steps. So let's look at the last example, and the last example, I believe it will be the one of arc 10 according to the order that we are following. So we will call it example 3. Like we are always doing, we are dividing our page. So our question is as follows, and mind you, like I said, I'm using simple examples in this. Then on the next video, we'll try to look at problems that are a little bit complex, and in that video we'll be focusing specifically on how to handle complex problems. But this time around, we are just looking at how the formula can be used. So we are having dy dx as our first step of writing the formula, f prime all over 1 plus f of x square. And then we said that our f of x is x plus 2. Our f prime x, this time around it will be 1, because when we differentiate 2, it's a constant. Then we finally apply our formula, and then we find that our f of x is 1. We put it there, 1 plus, we say that our f of x is x plus 2 square, we can simplify this, then it gives us 1 plus x squared plus 4x plus 4. Then we can simplify further by adding the like terms. We end up having x squared plus 4x plus 5. Thank you for watching this video. I hope you like and subscribe and help this channel grow. So we were actually looking at arc cos, arc sine, and arc tan. In the next videos, we'll look at more complicated problems, and we'll also look at hyperbolic functions. So since we have looked at how to apply these formulas, we can just make use of the same format in all the types, even whether it's an inverse, hyperbolic, or normal trigonometric function. Thank you. See you next time.